Okay, perfect.
Yeah, so introducing our speaker for tonight, Busra, who's a senior data analyst, come to talk to us about NLP. And yeah, Busra, do you want to go ahead and share your slides?
Okay, let me share my screen. Yeah. You can see, right?
Yeah, all looks
Perfect.
good.
Yeah. Okay. Hi, everyone. I'm Busra Ecem Sakar, senior data analyst at MolIQ. And I'm working on improving my skills in NLP for about a year now, so I'm new, but I'm really excited to be here today to share some insights into NLP, its techniques, and its real-world applications. And in this session, we will be covering general concepts in NLP to get you familiar with the basics. And I'm going to talk about a little bit technical informations about NLP, but also give some real-world application examples. Let's take a quick look at our agenda today. We will start with introduction to NLP, where I will explain the basics of NLP and why it is so important. And next, we will walk through the NLP pipeline, which covers the key steps of NLP. And after that, we will dive into common NLP techniques such as tokenization, stop word removal, and text vectorization. And these are fundamental tools that power NLP applications. And then we will explore some practical use cases to show how NLP is transforming industries like healthcare, finance, and marketing. Then we will wrap up with a list of references for further reading, and we will finish with question and answering part. Let's begin by understanding what is NLP. NLP is a branch of AI that allows computer to understand, interpret, and respond to human language. And the main goal here is to bridge the gap between human communication and machine understanding. So how does NLP work? It analyzes and processes vast amounts of unstructured text data. You can think about all the emails, social media posts, customer reviews, and other type of text data. And by processing this data, NLP can drive meaning, it can detect patterns, or it can generate actionable insights. Let me give you an example from the finance industry. When you make a payment, you might add a description. Let's say you are buying a PlayStation 4 from secondhand. Normally, if you are buying it for much lower price, normally the price would fall within a certain range, right? But if you are buying it for much lower price than usual, NLP can flag this as suspicious. It analyzes the text description of the payment and compares it with a typical price range to detect this potential fraud. Why it is so important? Because it automates text processing and allowing business to transform large data sets, large text data sets into meaningful insights. And also it supports smarter decision making, like detecting fraud, as we mentioned before. And also it is enhancing customer experience, and it is improving operational efficiency, like chatbots. So that's why it is important. Now let's take a closer look at the NLP pipeline, which outlines the key steps involved in building and deploying an NLP model. So we will start at the beginning of the pipeline with data gathering. This is the process of gathering the text data required for our NLP task. And data can come from different sources like customer reviews, social media posts, or business documents, or legal documents, or healthcare documents, for example. And once we have the data, we move to text preprocessing. This involves cleaning and preparing the text for analysis. And typical tasks here include tokenization, stop word removal, stemming, or lemmatization. And the goal is, in this step, the goal is transform raw data into a format that can be used by machine learning models. And the next, we have feature engineering, where we convert this pre-processed text into numerical feature. In this step, we can use techniques like TF-IDF, word embeddings, or backup words to turn the words into numbers. So these machine learning models can understand. And with the feature is ready, we process the modeling part. This is where the magic happens, exactly. We train our machine learning model to learn from the data and identify the patterns. Once the model is trained, we move to evaluation stage, where we analyze the model's performance by calculating metrics like accuracy, recall, F1 score, and based on the results, we can refine the model. So after that comes deployment. This is where the model is integrated into an application or system, making a real-time predictions or classification on new data. So finally, we enter the monitoring and model updating phase. Once the model is deployed, it's crucial to monitor its performance over time, especially as new data comes in. So we may need to update or retrain the model to keep it accurate and effective. But also, I want to mention a few important points. This pipeline actually is not a universal. It serves as a general guide, but pipelines may change depending on specific NLP task. And this is primarily for machine learning pipeline. And also, this pipeline is non-linear. This means this stage don't always follow a strict sequence. Some stage can have more dynamic connections. Let's talk about common NLP techniques. The first one is tokenization. Tokenization is the process of splitting a piece of text into smaller units called tokens. And these tokens can be individual words, sentences, or even phrases, depending on the application. And also it can change by language as well. There are different methods to perform tokenization. You can use NLTK library in Python, Spicy, or Keras also provide a method for text tokenization. Let's look at this example. In the sentences, women coding community empowers women in their tech careers. Tokenization splits it into individual words like women coding community empowers women in their tech careers. You can see how the sentences is broken down into these smaller units or tokens. And this process is so important for any further NLP task, whether it's sentiment analysis, translation, or text classification. Because by applying tokenization, we actually turn unstructured text into structured data, so that can be processed by algorithms. The next technique we will cover is stop word removal. Stop words are common words that don't add much meaning to the sentences on their own. For example, the, is, and. The purpose of stop word removal is to reduce noise in the data, and which can help improve the performance and accuracy of NLP models. Again, there are few methods you can use. You can use again NLTK for this and Spicy. And Jensen also provides stop word lists. You can work on that. When we look at this example, women coding community empowers women in their tech careers. After tokenizing the text, we can remove stop words like in and there. You can see the stop word removal process is the unimportant words removed and the significant ones remaining. This technique is crucial in the text pre-processing and helps model concentrate on most relevant data for the task. But I want to mention one important point. Removing words like is can change the meaning of a sentences because they play an important role in the sentence meaning. Stop words removal is useful in many tasks, but we need to be careful, especially in task where understanding the full meaning and structure of the sentences, like sentiment analysis. So I think this is important. It's depend on the application you want to work. It's change. Let's move on another important pre-processing step, stemming and lemmatization. Both of these techniques aim to reduce words into their root or base form, but they do this in different ways. First, let's talk about stemming. Stemming is a more straightforward method where chop off word endings to get the base form. For example, running becomes run. Lemmatization, on the other hand, it is more sophisticated. It used a dictionary and grammatical analysis to convert words into their proper base form. For example, better become good, went become go. So why this technique is useful? Because they help us to treat different forms of the same word as a single word. Both of these techniques are important for normalizing text and preparing it for further analysis. You can use, again, NLTK library for this. So let's move. Now we will explore name entity recognition, or NER. The purpose of NER is to identify and classify name entities within a given text. These entities typically include things like people, locations, and dates. It is incredibly useful for extracting key pieces of information from large amounts of text. For example, in the legal domain, it can extract the names of people and organizations from contracts or legal documents. In healthcare, it can help identify patient names, diagnosis, or medications from doctor's notes. In finance, it can be used to extract, again, company names, locations, transactions data. So let's look at an example using Spicy. In the sentences, Apple is looking at buying a startup in San Francisco for 1 billion. The NER model has classified, for example, Apple as organization, San Francisco as location, and 1 billion as a money. So you can see how Spicy has detected and labeled these entities in the text. So it is really a powerful method for domains like finance and healthcare. Next, let's explore part of speech post-tagging. It's a technique that assigns grammatical labels such as noun, verb, adjective to each word in the sentences. And the main purpose of post-tagging is to help us to understand the structure of sentences, making it especially useful in syntactic parsing and other grammar-related NLP tasks. You can use, again, Spicy and NLTK for this. There are lots of methods for this, but spicy and analytic is the best one. For example, when we analyze the sentences, VCC hosts workshops to help women learn coding and build networks. So post-tagging assign each word a tag that indicates its grammatical role in the sentences. For example, VCC and NNP stands for proper noun singular, which is correct for VCC because it's the name of a specific organization. Or let's say build. Build is in its base form and used as a verb here. So it is tagged by VB, indicating an action. So by applying this post-tagging, we can break down the grammatical structure of sentences, which is essential for many NLP tasks such as machine translation, synthetic parsing, or even question and answering systems. Let's dive into crucial steps in NLP, which is text vectorization. This is the process of converting raw text into numerical features. Since machine learning models work with numbers, text must first be transformed into a format they can understand. There are two main approaches we commonly use for text vectorization: TF-IDF and bag of words. In the next two slides, we will explore these two methods in more detail. I get this image from NLP Planet. Let's talk about this image. We start with two row sentences. Basketball is a team sport where teams shoot a basketball, and football is a sport where teams score goals. And after vectorization, we get a numerical representation for where each word is listed, and its frequency in each sentence is counted. For example, basketball appears twice in the first sentences, while football appears once in the second sentences. These techniques are widely used in applications like text classification, sentiment analysis, and topic modeling because they help convert text into a format suitable for machine learning models. Let's take a closer look at the bag of words model, which is the one of simplest and most commonly used text vectorization techniques. With bag of words, we represent a text by counting how often each word appears in a document. This gives us a structured way to convert text into numbers. For example, in document 1, we have the cat sat on the mat, and the document 2, the dog sat on the log. And after applying this model, we create a table where each unique word from both documents is assigned a column. For each document, we count how often each word appears. For example, the appears for the document 1, the appears twice, cat appears once, and dog does not appear at all, so it counts as 0. So this model only captures the count of each word, but it doesn't tell us anything about how important the word is in the overall document or corpus. So that's why we have TF-IDF, which stands for time frequency inverse document frequency. This is widely used statistical measure in NLP that help us to determine how important a word is within a document relative to a collection of documents known as corpus. The formula for TF-IDF is combination 2 matrix, term frequency and inverse document frequency. Term frequency is simply the number of times a word appears in a document divided by the total number of words in that document. So it gives us an idea of how often a word is used in the document, but it doesn't necessarily mean the word is important. But on the other hand, inverse document frequency measures how unique or rare a word is across all the documents in the corpus. Um, and we get this TF-IDF score. We multiply these two values together, and the results tell us how relevant a word is to a specific document compared to the rest of the corpus. Let's go through a specific example for this method. Again, we have same document. The cat sat on the mat and the dog sat on the log. After applying TDF, we get a table like the one shown here. For example, the word cat in the document 1 has a TF-IDF score value of 0.05, while in document 2, the words dog and log also similar TF-IDF values. Let's break down how this TF-IDF value for cat was calculated. Term TF for cat in document 1, the word cat appears once in document 1, and in document 1 has a total of 6 words. The cat sat on the mat, right? So the term frequency for cat in the document 1 is 1 divided by 6, which is 0.16. However, let's also calculate inverse document frequency for cat. There are 2 documents in total, and the word cat appears only 1 document. So IDF for cat is calculated as log 2 divided by 1, which give us approximately 0.30. And the TF-IDF score for cat in document 1 is calculated by multiplying the TF and IDF values, which is approximately 0.05. So as you can see, the word cat is unique to document 1, so it gets a higher TF-IDF score and making it more important in this document compared to other common words like the, which have a TF-IDF value of 0 because they appear frequently across both documents. This example demonstrates how TF-IDF helps to prioritize meaningful words in a document by giving higher scores to words that are unique or rare across the entire set of documents. It is especially useful for tasks like document classification, information retrieval, where we want to focus on the most important words. And also, I want to talk about Cosign Similarity because it's a very useful, powerful technique in NLP for comparing the similarity between two texts. Whether you are working with documents, sentences, or word embeddings, Cosign Similarity helps quantify how similar these texts are, which is particularly useful in tasks like document clustering, information retrieval, and text similarity analysis. And it's especially important when we convert text into numerical vector representations using methods like TF-IDF, Word2Vec, or BERT embeddings. Cosign similarity allows us to compare these vectors and understand the degree of similarity between them. Let's look at the image for visual understanding. In the top left, when the angle equals 0 degrees, the cosine similarity is 1, meaning the vectors are most similar with a distance of 0. In the top right, with an angle of 30 degrees, the cosine similarity is 0.86, meaning the vectors are somewhat similar with a distance of 0.14. In the bottom left, the angle equal 90 degrees. The cosine similarity is 0, indicating the vectors are unrelated. In the bottom right, when the angle equals 118 degrees, the cosine similarity is -1, showing the vectors are opposite within a distance of 2. So by calculating this cosine similarity, we can assess how closely related two documents or sentences. And this method, as I mentioned before, useful tasks like text classification, recommendation systems, and more. And let's now turn our attention to another widely used NLP techniques, sentiment analysis. The purpose of sentiment analysis is to determine whether the sentiment expressed in a piece of text is positive, negative, or neutral. This technique is incredibly valuable in various domains where understanding the emotion tone of text is crucial. For example, this method can use in social media monitoring, where companies can track how their brand is perceived in real time, or it can be useful for product reviews to analyze how customers feel about a product. And also, it can be useful for customer feedback analysis, where business can understand public opinion and make a data-driven decision based on the sentiment. There are several methods that we can use. Wider sentiment analysis in NLTK is very powerful. Textual also it's very powerful, and Hugging Face transformers also provides pre-trained models. I will explain more Hugging Face in the next slide because I think it's really important and helpful for starting an NLP. Let's move the next slide. Hugging Face, it's a leading platform and a company in the field of natural language processing and machine learning. Hugging Face has transformed the way developers and researchers build AI applications by providing them easy-to-use tools, pre-trained models, and libraries of so they can use their AI projects. They have some key aspects. Transformers library, for example, this is an open source Python library that offers state-of-the-art transform models like BERT, GPT, T5. So you can use these advanced model very easily. And Model Hub, Hugging Face provides a community-driven repository where users can find thousands of pre-trained models for different languages and tasks. And it's a place where users can not only download the models but also share and contribute their own models to community. And there's a pipelines. So you can use these pre-trained models through pipelines, which are easy to use interfaces for performing NLP tasks such as sentiment analysis, text summarization, question answering with just a few lines of code. And they have also community. One of the Hugging Face trait is, sorry, is its vibrant community of researchers and developers. And this community actively contributes models, and you can find open source, open data sets and tools. They actually foster a collaborative ecosystem where the best resources are shared for everyone's benefit, actually. So let's also move on another common task text classification. The purpose of this method is automatically assign predefined categories or labels. For example, this method can use for spam detection, where the emails are classified as spam or not spam, or topic classification, where the documents or articles is categorized into specific topics like sports, business, or technology. And also it can be useful for sentiment analysis where text is categorized as expressing positive, negative, or neutral sentiment. So you can use scikit-learn for this method, and also for more advanced models, Hugging Face transformers, as I mentioned before, provide pre-trained models that can be easily accessed. For example, if input is this email is about upcoming conference, the system might classify this text under the category business. So it is working like this. And text classification is powerful tool used across industries, from automated customer support, content moderation, or recommendation systems. So let's move word embeddings methods. It is this technique. It's a technique used to represent words in a way that captures their meaning and context in a numerical format. It's a little bit advanced technique. But in general, the purpose of word embeddings is to turn words into dense vectors, which are essentially list of numbers. So these vectors allow us to understand relationship between words. But how do word embeddings understand the meaning of words? Basically, it's based on the idea that words used in similar contexts tend to have similar meanings. For example, if you see the word king in the sentences, like the king rules the kingdom, the king and queen are royalty. The word king often appears near words like queen, kingdom, loyalty, right? So this model learns that words appearing in similar contexts have similar meanings. So when it turns words into vectors, words like king and queen, they will have similar vectors because they often appear in similar context. And what is, sorry, I need water, so sorry. Why it is useful? Because it's great for tasks like semantic analysis, where we need to understand how words relate to each other. Text classification, again, where these word vectors can be used as feature in the machine learning models. Similarity search, where we can find words or documents are similar in meaning. There are few ways to create word embeddings, Word2Vec, Glow, and BERT. And Hugging Face transformers also provide these models. And the last technique, topic modeling, LDA. The purpose of topic modeling is to discover the underlying abstract topics within a large of documents. For example, if you have a collection of news articles, topic modeling can help you to automatically discover themes like politics, technology, or sports. So some key use cases for topic modeling, like also we can use it in customer feedback, like you could catch themes like product quality, pricing, or customer service by using LDI model. Again, there's a few ways to perform topic modeling. Gensim also provide LDA model you can use. Basically, topic modeling helps you make sense of large collection of text by organizing them into meaningful categories. It's saving time and revealing insights that would be hard to find manually. Exactly. So let's take a look at some practical use cases of NLP in different industries. I tried to choose real-world examples. For example, customer feedback analysis. Amazon use NLP to analyze millions of product reviews, and by identifying customer sentiment with models like BERT, for sentiment analysis, and methods like LDA, which we mentioned just 1 minute before, for topic modeling, they can understand what customers are saying about different products. And Amazon also use name entity recognition to extract product names, brands, and specific features from reviews, allowing them to fine-tune product recommendations. This helps Amazon tailor their services to better meet customer needs. And also chatbots and virtual assistant, they are using NLP. For example, Bank of America uses its virtual assistant Erica which is powered by NLP. And Erica helps customer with tasks like checking balances, paying bills, and it also provides some financial advice. So it's likely uses models, pre-trained language models such as BERT to understand users' intent. And also name entity recognition, again, is used to process to customer input and extract key entities like account numbers, dates, and amounts. Once Erica understands the query, it generates human-like responses with GPT-based models to guide the user through their task. This is a great example of how NLP is making virtual assistant more conversional and more human way. In the healthcare, IBM Watson Health uses NLP to help diagnose diseases by analyzing patient data such as medical record. They are using medical name entity recognition to identify diseases, treatments, and symptoms, for example. They use text classification models like BioBERT to categorize medical notes. This Watson can detect patterns that might indicate a specific condition, and this technology helps doctors make more informed decision about patient care. In finance, Monzo, a digital bank, employs NLP for fraud detection and risk assessment. Anomaly detection models like BERT analyze transaction data to identify suspicious activities. Monzo also analyzed transaction description. As at the beginning, I give an example about finance. It's actually from Monzo. Because Monzo analyzed these transaction description and customer support interaction as well using name entity recognition and sentiment analysis to detect potential fraud. Um, in the marketing, Spotify uses NLP to analyze user listening habits and preference by employing collaborative filtering along with the models like Word Embedics, Word2Vec, Word, to understand song metadata and lyrics. And Spotify generates personalized playlists and recommendations by analyzing user behavior and metadata. So these examples highlight how NLP is driving innovations across multiple industries, helping business make a smarter decision and offer more personalized services. And NLP is not just about processing language, it's about transforming raw data into meaningful insight that drive real-world applications. So before we conclude, I want to mention some key resources and tools that help inform today's presentation. And the Hugging Face Transformers library and Jensen, they are widely used for implementing NLP techniques like text classification, sentiment analysis, or topic modeling. And the platform like Spicy and NLTK are essential for text pre-processing tasks like tokenization, stop word removal. Additionally, I want to mention about NLP Planet website. It's really useful. It's contain lots of information about NLP, and the Oracle website, I use some images from Oracle website. I think these resources offer fantastic explanations and tools to get a hands-on experience with NLP task. I hope you gain valuable insights into how NLP can be applied across various industries, from customer feedback analysis to finance, healthcare, and beyond. So thank you for all your time and attention today. If you have any question, you can please feel free to ask. And if you like to dive deeper or explore some real world case studies, feel free to reach out our community. to ask another session. Thank you.